In today's lesson, we're going to introduce the idea of circle theorems. There are 7 facts that you need to know in total, and we're going to introduce 2 of them today. Before we do this, it's important that you understand the definition of certain properties of circles. Firstly, this blue line that we're given just here, which goes from the centre to the outside, is called our radius. The red line that we're given, which goes from one side of the circle to the other, passing through the centre, is called the diameter. The purple line represents the tangent to our circle. Specifically, this is the tangent to our circle at point B. A tangent is a line which touches the circle at exactly one point. So here's some variations of a tangent. In our second circle, the line DE, which goes from one point on our circumference to another, is called a chord. Lastly, the curved part of the circumference between these 2 points is called an arc. Additionally, if we take 2 lines which represent the radius of our circle and join them together with an arc, the area which is represented by this green space is called a sector. A sector is very much like a pizza slice. If it's a smaller part of the circle, it's called a minor sector. The bigger part which is left over is called the major sector. Likewise, if I take a chord and an arc, this orange area that is formed between them is called a segment. Again, the smaller part of the circle is called a minor segment, and the larger part is a major segment. Using these definitions and the angle facts that we know, we can already start to work out some missing angles in circles. Whilst these are not circle theorems themselves, they do demonstrate the importance of understanding our circle properties. Often, lines representing the radius of our circle will be used to form isosceles triangles, and this will allow us to calculate further information. Here I'm going to go through some examples of this. In this first example, I should be able to recognise that this triangle we're given is isosceles. That's because the line OA and OB are equal, as they both represent the radius of the circle. From this, I can therefore say that this angle must also be x because it's isosceles and they're the same. I can work out x by starting off with 180, that's the sum of angles in my triangle, take away 100, which is the angle I'm given. That leaves me with 80 degrees. Because I have 2 angles which are equal, I want to share this 80 degrees between both of them, which leaves me with 40 left over. So therefore x is equal to 40 degrees. In my second example, I'm given some parallel lines. Because of that, I can say that this angle just here must be 50 because alternate angles are equal. Just like the first example, I can say that this line and this line are equal, and therefore it forms an isosceles triangle, meaning that this angle here must be 50. I know that the line OB and OC are equal because again they both represent the radius of my circle. From here I can work out my missing angle Y because angles in a triangle add up to 180 degrees. The angles I'm given are 50 and 50, which is 100 degrees. If I take 100 away from 180, I get 80 left over, meaning that my missing angle Y is 80 degrees. In my last example, again I can use the fact that OD and OC are the same, as they both represent the radius, to say that this angle must be 65 degrees as well. 65 add 65, gives me 130 degrees, and therefore because angles in a triangle add up to 180, I know that the missing angle at the top must be 50 degrees, this angle just here. Lastly, I can work out Z because angles on a straight line add up to 180, so I simply do 180, subtract the 50 degrees that I've got, and that gives me 130. So therefore, Z equals 130 degrees. I can obviously use some of my other angle facts, such as vertically opposite angles, to help me find some of the other missing angles in this circle. Another important definition that you need to understand is the word subtend. Angles are created by two lines joining. The points where those lines start are the points that subtend the angle. In the picture, there are two sticks leaning together that form an angle. We can say that the highlighted angle is subtended by the ground. Likewise, in this example here, the lines that make up the angle start on the circumference, therefore we can say that the highlighted angle is subtended on the circumference of our circle. At this point we can finally introduce our first circle theorem. This one I refer to as a triangle because you can see the 3 points make a triangle in your circle. As I move the points around, you might be able to see that there's one thing that stays the same regardless of where I move the points to. That is that the angle at C is always a right angle. There's a few things that you need to notice. First of all, this line AB is always the diameter of your circle, and the angle opposite it, which in this case is C, will always be a right angle. We can therefore say the angle in a semicircle is always a right angle. Here's an example of how we might use the triangle circle theorem to get the answer to a question. Part B is asking us to work out the value of x. Now, because this line here is the diameter of our circle and it's used to make up a triangle, we can say that this angle opposite our diameter must be 90 degrees. That's because the angle in a semicircle is 90. I need to work out what this angle here is, because if I can get that, I can work out x, because both of them will add to give 90 degrees. I can work out that angle by saying that this length and this length are equal because they both represent the radius of my circle. As such, the triangle that's formed down the bottom must be isosceles, meaning this angle is 48 degrees as well. From here, I can work out my missing angle x by doing 90 subtract 48. So firstly, I need to borrow. I get 10 take away 8, which is 2, and 8 take away 4, which is 4, meaning that my missing angle x is 42 degrees. Here is the second and final circle theorem of today's lesson. This one I refer to as the arrow. As I move the points around the circumference of my circle, is there anything that you notice about the angles inside the arrow? This might help. What this circle theorem says is that the angle at the centre is always twice the angle at the circumference. There's a few important things to notice. Firstly, 3 out of the 4 points must be on the circumference of our circle, and the final point must be at the centre. Another thing that's important to note is where the angles are. The smaller of the two angles is inside the arrow at the top, whereas the angle at the centre is outside of the arrow, and that's always double the smaller angle. Just like before, here's an example of how to work out a missing angle using this circle theorem. Part B asks me to work out the missing value x. I can spot that there's an arrow because the centre point is used and the 3 other points are on the circumference of my circle. I'm given the angle at the centre, and I know that this is twice the angle at the circumference, so therefore I need to halve 128 to find out x. 128 divided by 2 is 64, and therefore x is equal to 64 degrees. As I've mentioned before, just be careful to think about the angles that you've been given and whether you need to double or half them. Likewise, if you're given this angle on the inside, you're going to have to use the fact that angles at a point add up to 360 degrees to work out the relevant angles before you can apply this circle theorem. So your task today is to complete the 2 worksheets which are on screen right now. They're attached to show my homework, so if you do have printing facilities, I strongly recommend printing them off and writing on the sheet. You can, however, work from the screen if that is more convenient for you. Please pause the video and have a go at the questions now. Once you're ready for the answers, simply resume the video. Here are your answers. Please make sure you check your work extremely carefully. If there's anything that you're unsure about, please don't hesitate to get in touch and ask the question. Once you're happy with your final bit of work, take a photo of it and submit it to Show My Homework so I can see how you've got on. If you are struggling to complete some of the work from today's lesson, then please do not hesitate to get in touch via comment on Show My Homework. I'll try to make myself as available as possible and get a reply to you as quickly as I can. If the issue requires a little bit more input from myself, I might ask to arrange a time to meet on Teams where I can give you some personalised help with that specific problem.